Hello everyone, I'm Sreesh Kakulo and I welcome you to our IISWC 2020 presentation on our work titled Characterizing the Scale-Up Performance of Microservices using TeaStore. In our work, we present the first systematic study of microservice performance in a scale-up environment on a state-of-the-art x86 server supporting 128 logical CPUs per socket. This is joint work done with Kanishka Lahiri and KV Subramanian. The key contributions of our work are the following. First, we find that the operating system does poorly in terms of scheduling microservice threads on a modern high core count server. This leads to poor throughput and latency at the application level. Next, we demonstrate the significant performance opportunity that exists if knowledge of the topology of the underlying server is properly exploited. Topology awareness allowed us to get throughput gains of 22% and a mean latency reduction of 18% over a tuned baseline of the application that we studied, that is TeaStore. Finally, via a similarity analysis, we demonstrate that microservices have major differences with respect to Spec Rate 2017 integer benchmarks, which are typically used to drive processor design today. I now present the chart that is central to our work. It illustrates the performance scaling of microservice benchmark TeaStore versus core count. The experiments were done on a AMD EPYC 7742 server with 64 cores and 128 logical CPUs per socket. So we have the throughput on the y-axis versus core count on the x-axis for three different configurations of TeaStore. The default, in which we make no changes to the workload. The scale service, in which we scale instances of microservices which are unable to scale up with high core counts. And the topology-aware configuration, which we craft on top of scale service configuration to run with the knowledge of the underlying server topology. Coming to the performance numbers, with an 8x increase in cores going from 8 cores to 64 cores, the default configuration scales by just 2.9x, while the scale service and topology-aware configurations scale by 5.7x and 7x respectively. These throughput numbers were also accompanied by improvements to the latency of the application. The primary takeaway here is to note the performance opportunity that exists for microservices on modern high core count servers when the scaling behavior of the application and the topology of the underlying server is properly exploited. Not doing so leaves a lot of performance on the table. In our complete work, we describe in detail the methodology used to arrive at these configurations. I will now pause for a moment on the disclaimers and attributions slide. That brings us to the end of our short overview. Thank you.